Hello, Mr. K here, talking about code readers and scanners again today. But we're gonna roll on with part 3. I think we're gonna just leave it at 3 parts because we're starting to get pretty in depth here, and even this presentation might be a little difficult to follow for some of you who are watching. So don't feel bad if you can't quite keep up with everything. Just try to absorb as much as you can. Today we're talking about freeze frame, live data, and the troubleshooter function on our scanner. If all this stuff sounds foreign to you, don't worry about it. We're going to explain it. So first thing we want to do before we jump into all those other things is we are going to talk about why does any of this stuff matter? Why do we care about this when we already know how to scan for codes and actually read the codes? Why do we care about looking at the data? And of course, we're going to talk about live data, also called the PID view parameter ID, right? Freeze frame, and the built-in troubleshooter on our Snap-on scanner. So first things first, why do we care about any of this when we already have trouble codes? Because if you pull this code on a scanner or a code reader, I put some ideas up here, but what does that really mean? Does that tell you what parts you have to order? Does it tell you how much the job is going to be? Does it give you an idea of when you're going to be finished with this vehicle? You can tell the customer to pick it up. What does it really tell you? It doesn't really tell you anything other than just that cylinder 3 isn't firing correctly. But these questions are not answered. So the next step for a lot of mechanics is to jump into the live view or the PID readings. So on a pretty high-end scanner, this is what it might look like. I just kind of put this picture up here because it's laid out well. It's got different colors and it looks neat. You probably would never see this exact scenario if you're looking at a live view, but just to give you the idea, it'll have some graphs, and this one's obviously, you see this showing engine speed, your RPM. We're looking at, let's see, this looks like oxygen sensor readings and mass airflow sensor readings down here. Again, if you don't know what these things mean, that's fine. We're not here to dive into those today. I'm gonna show you a trick on how to tell how to use these live data readings, but it's okay if you don't know what math means and what an oxygen sensor is. So the things that I want to just get into your brain today is when you're looking at a live view or the PIDs, do things look like they make sense? Even if you don't know what everything is, do you see patterns that make sense? Do you see values that make sense? So if we're looking at this graph in here, engine speed's going all over the place. Okay, I guess you could simulate this is a guy sitting there just hitting the gas, revving it up over and over and over again. It would probably make sense that there would be some other things in the engine that are kind of going in a similar direction, right? So to me, this looks normal. It makes sense. Okay, let's look at PIDs on this engine. We're looking at idle air controller position. Okay, and let's say, let's go ahead and look. You got desired and the actual position. So desired means the ECU is telling it to go to this position, and then actual is the sensor on the unit itself saying where it physically is. And you can see there is a little bit of difference in them. You see that little shape down at the bottom versus here. Okay, so they're not exactly the same, but to me they are pretty similar. So that's a good thing, right? What the computer's saying is actually what's happening. So that's one step in the right direction. Do the values make sense? I guess it depends on the situation. Maybe if, say, you're sitting in a car idling at a stoplight, or if you're watching the live view, hopefully you're not driving, but say your car's idling and all of a sudden you kick on the air conditioning, it's going to drag down on the motor a little bit, and that could be where this little step is. But let's say let's see. Let's say you're just idling for the last 5 minutes and you never touched the gas and the motor never changed speed. Does that make sense now? Probably not. That probably shouldn't be something like that. let's follow that same logic on this. Okay, let's say this is the last minute of time of the engine running, and that RPM's just going crazy. Engine speeds go all over the place at this top graph. But look, the computer for the last minute has desired, or it has commanded the engine to just keep idling at 550 RPM. But the engine speed is just going crazy. This is where you have to figure out, well, did you actually hear the engine revving up? Is it truly going crazy like what this upper graph is showing? And if that's the case, then you may have a throttle controller that's bad, or a pedal position sensor for your gas pedal. And if it's not, if that's not the case, and that your engine has truly been idling, then you probably have an engine speed sensor, or which probably a crank position sensor that's going bad. But you have a sensor on the engine that's going bad because it's reading crazy, but the engine's not going crazy. Okay. So hopefully you're starting to get an idea of why this live data is important, because again, this P0303 code just doesn't really tell us anything. But when you start digging through live data or similar code, it doesn't tell us a whole lot. When you start digging through live data, you can really see what the computer is seeing. All right, this time go ahead and watch this video, OBD2 full scan data, live data. It's going to show you just an example of all the live data that you can pull out on a scan tool. Okay, you should have just watched that video, and that was just scrolled through live data on a scan tool. It's okay if you don't know what most of that stuff means, but I just wanted to get an idea of what it looks like. And that was actually an engine that was running while he was showing you that. All right. So what if you get a check engine light on a vehicle, but when you pull all the live feed, everything looks normal? And let's say it's a check engine light for let's say throttle position sensor, check engine light for that. But when you pull up the live view, everything looks normal for throttle position sensor. So you'd like to actually see what caused that check engine light to turn on. That is where the freeze frame data comes into effect. All right, freeze frame data is just a screenshot of data from when the check engine light was turned on. So it's not live data. It could be data from a week ago, but freeze frame data is automatically saved by the ECU, and you can pull it later on with a scanner, and it will show you exactly why that engine light was kicked on by the ECU. Why did the ECU feel that there was a problem? So it saves a screenshot of all that live data from that exact moment when it kicked the engine light on. And this would just be an example. But before you delve into that too hard, why don't you go ahead and watch this video at the bottom for diagnostic freeze frame data. All right, you should have just watched that video. Hopefully that gives you a little bit of more of a grasp on what freeze frame is. And we're going to look at some examples now. Before we leave this slide, actually, just for more practice here, I want you to go down and look at all these and find something that just doesn't look like it makes sense. Something that just seems a little off. Okay, you can pause the video if you need to. But hopefully, a couple things grabbed your attention here, hopefully. First of all, engine RPM, 381 RPM. That is awfully low. Vehicle speed, 9 miles per hour, right? 9.3 miles. So they weren't just sitting there idling. I mean, they were driving. I don't know why an engine would be that low in RPM unless it's dying, which maybe that's the case, but my gosh, that is really slow for an engine to be turning. I would expect typically nothing ever under about 500, 550. So that's odd. Come up here, short-term fuel trim, long-term fuel trim, short-term, long-term. Notice all these numbers hover around 0 roughly, and then this one's negative 33. That should be a red flag. Something's going on there. Let's find another value in here that doesn't make sense. All right. Vehicle speed, okay. The guy was just sitting still apparently. Engine speed, 681. That sounds reasonable. Intake manifold pressure, 101 kPa. 14.6 PSI absolute. That's a little odd. That doesn't sound right to me, but we can delve into that at another time. Let's look at fuel trims again. Again, close to 0, and all of a sudden we got 15. Something's a little weird there. Okay. Coolant temperature 100 degrees C or 212 degrees F. That's reasonable. Calculated load 22%. Yep, reasonable. Fuel system status, closed loop on both of them. That's also reasonable. Okay. So again, something doesn't make sense there. And I'm not asking you to interpret what that means. I'm just asking you to find the value that doesn't make sense. How about here? Here's some more freeze frame data. Okay, again, this was taken when the vehicle check engine light was kicked on. There's only 4 values here, and there's one of them that doesn't make much sense. All right. 16% load on the engine, that's reasonable. Yeah, just cruising down the street at 20, 30 miles an hour, I could see 16% load. Control module voltage, or the voltage going to the OBD port, 9.13. That is a strange number. I don't know why anything would be 9.13 volts that the scanner would be reading. So that tells me we might have a problem with our battery or our charging system, because that's not right. Shouldn't be 9 point. Should be maybe somewhere between 12.5 to 14.5. Should not be 9. Okay. Barometric pressure, that sounds reasonable. Fuel level input, about a quarter tank, right? That sounds reasonable. Okay, there's your problem. You may not have a problem with a sensor after all, or the engine could be fine. You've got a problem with your battery or charging system, and that happened to make the engine run poorly. Maybe fuel pump wasn't running correctly, injectors didn't fire long enough, but all because of that battery voltage. So this is why freeze frame data can be very valuable. All right, we are really getting complex here. Don't let it overwhelm you. Even if you don't know what most of this stuff means, again, just start looking for something that looks a little odd. The more you look at these, the more you'll realize what makes sense and what doesn't. But again, looking at these fuel trims, these two guys are negative, but yet the other side of the engine, fuel trim for bank 2, positive. A little odd, right? Also, vehicle speed sensor, VSS, reading 0 miles per hour. So you say, oh, okay, well, he must be idling. Well, then how is the engine percentage load at 47%? 47% would be, I mean, that's a lot of load. 50% throttle on an engine is taken off. I mean, that could be merging on the highway. That could be taken off from a red light. But that doesn't make sense to me that vehicle speed is going to be 0. That just seems a little odd. Maybe it was right at the second when they're hitting the gas coming off the red light. I don't know. And we already talked about bank 1 and bank 2, one being positive, one being negative. Again, don't let this data overwhelm you. Just look for the things that don't make sense. Okay, so you've gone through the live data. You've looked at the trouble code. You've gone through the live data. You've gone through the PIDs. You've gone through the freeze frame data, and you're still just not sure what to do. Or maybe it didn't make sense to you. Luckily, we have an answer for that. Especially if you have a Snap-on scanner, they have installed a troubleshooter for you. This is actually a pretty neat video. So go ahead and pause my video right now and watch this. Okay, you should have just watched that video. Hopefully that gave you a little insight on how the troubleshooting tool can help you, and you take advantage of it. At this point in time, go ahead and complete your assignment on Code Readers and Scanners, Part 3. And have a good day.